Hi, my name is Robert, and this is a demo for the PerceptiLabs modeling tool. When you first enter the tool, you'll be presented by a project screen where you can view all your different projects. I currently only have one project, so let's jump straight into that one. When you enter a project, you can see all your different models which exist inside that project. You can see their different statuses, if and where they were exported or saved to, how long time it took to train each model, who actually worked on the model, as well as when it was last updated. For this demo, I'm going to create a GAN, a generative adversarial network. To create this GAN, the first thing I need to do is to create a new model. When creating a new model, you have a selection of a few different templates. But for the purpose of this one, we're just going to use an empty template. As soon as you create a new model, you get thrown into the modeling workspace. Here is where you will create your model using the PerceptiLabs drag and drop tool. You do it by dragging and dropping in different components and combining them together with arrows in a dataflow-driven manner. The different components you can find up here to the left. They're sorted in different categories, where we have the data components, the pre-processing components, the deep learning components, the mathematics components, and the training components. I'll talk a little bit more about the training components later on, but these are the ones which let you build a high variety of different models using a very simple architecture structure. We also have classic machine learning components as well as a custom component. The custom component is essentially a blank component in case you want to custom create it on your own. To start building the GAN, I'm going to drag out a random noise generator. This will act as an input to the generator part of the GAN and will later on generate images which looks like the real images. I'll change so it outputs 100 random values, and we can leave the mean and standard deviation as they are right now. As soon as you apply a component, you'll see a preview of the output of it. You can also see a dimension popping up right above the component, and this will help you as you're building out your model to keep track of how the network architecture looks like. For the generated part of the model, I'm going to create a very simple two-layer fully connected network. I'll put the first one to 128 neurons. And the second one to 784, which will be the same shape as the real images. Also, while we're in this component, I can highlight that each of these components are just a template which generates code in the background. The code which is being generated is what is actually being ran when you're executing the model. To see this code, you can press this Code tab and you'll get full transparency of exactly what is being executed in your components. You can also fully custom edit this component if you want to create something where the settings are not enough. Finally, I'll add a reshape component to reshape this 784 output into an image to make it a little bit nicer to look at. Now that the generated part is done, I'll add some real data for it to train against. The real data I'm going to add in is a dataset called MNIST. It's handwritten digits between 0 and 9, and it's a very common dataset to test your models against. To add this data, I'll drag out a data component and select the file which I want to load. As we can see, the MNIST data is not actually an image right now. This is because the image has been flattened and we need to reshape it back into its original form. To do that, just like before, I'll add another reshape component. And apply it. And then we can see how the real image would look like. Now I'm going to add a switch component. This component allows the model to switch between two different inputs. In this case, it's going to switch between a generated image and a real image. It does this to be able to learn, or try to learn, which image is false or generated and which image is real. The only setting in the switch layer is which components you would start with, and in our case we'll start with the generated image. Now that that's done, we're going to build a discriminator. This discriminator is the one which will try to say if it's a real image or a false one. And the entire purpose of this GAN is the generator part of the model is going to try to compete against the discriminated part of the model to see if it can generate images which are more realistic than the discriminator can say which is which. For the discriminated part, it's going to be even simpler than the generated part. We'll have a fully connected component with 128 neurons, just like before. And then a very simple fully connected component with just one neuron and no activation function. The reason for this is that all this one is going to do is say zeros in case it's a false if it's not a real image, and ones if it is a real image. Now the model is almost ready. The last thing we need is a training component. So I'm going to drag out a GAN training component and connect it to the end of the discriminator. Except for just running the training loop, this training component also provides almost all the visualizations which we're going to see in the statistic view when we start running the model. In the training component, you have to select which component is the switch and also where the real data comes from. I'm also going to change the batch size from 3 to 100 to make the model a little bit more efficient. Now that the model is finished, we can start training it. To start training your model, all you need to do is press the Run button and then Start. As soon as you do this, you get thrown into a statistic view. This statistic view will give you an overview of how the training goes during the entire training process. In the top part, you'll be able to see an overview of the network as a whole. What we're currently looking at is the real image compared to a generated output. If you remember how the generated image looked before, it was just random noise, while it now already has started learning something. You can see how it's trying to create something which looks like an image. Except for this, we can also see the generator loss, as well as the discriminator loss. And these are measures of how well or poorly this part of the model is doing. The higher the loss, the worse it's doing. How it works though is that generally the generator loss is going to go up if the discriminator loss goes down. This is because the generator and the discriminator are constantly combating each other to see which one can generate the best image versus which one can see if the image is real or not. So the generator is trying to generate images to trick the discriminator, while the discriminator is trying to get as good as possible on telling if the image is real or not. Finally, in the overview, we have the data distribution, where you can see the distribution of the real data in the red pixels, or red dots, and the distribution of the generated image as the blue dots. Ultimately, you would want a red and blue distribution to end up very similar to each other. Finally, in the bottom right, we have something which we call the view box. The view box is a way to peek into each of the different components inside of the model. To peek into different components, you can press on the map over to the left. Doing this will let you see things such as the outputs of the components, the gradients of the components, as well as the weights and biases of the components. All of this is updated in real time, and its purpose is for you to very easily be able to look through your model and debug what's actually going on. As this one is going to take a while, I'm going to leave the demo here, and I hope it gave a good overview of what you can do in the PerceptiLabs modeling tool. If you want to try it out yourself, you can go to our website, PerceptiLabs.com, and there is a very easy install through pip, so you can install it on your local machine and try it out. We're constantly updating the tool, so any feedback you have is greatly appreciated. And that's everything from me. Thanks.